Alright, what I'm going to do in this video is show you how to calculate the confidence interval for the population mean when the population standard deviation is unknown, which requires you to use the t-distribution with n-1 degrees of freedom. Remember, this happens when you're looking at a bunch of data, and say you have 50 pieces of data on some variable, and you calculate a mean, sample mean of that data, and you want to use that sample mean to estimate the population mean. But the only problem is you don't know the population standard deviation. So what you do is you use that same data and calculate a sample standard deviation. So you're using the sample mean and the sample standard deviation in order to calculate an estimate for the population mean, requiring you to use the t-distribution. All right, so JUMP has some really nice features built in to do this. So what I'm going to do is let's open up a data set in JUMP. So in the Help menu in the Sample Data Library, JUMP has tons of data sets, and one of them that I like to use from time to time is called Big Data. Big Class, there it is. Big Class. So I'm going to open up Big Class, and what Big Class is it is 40 males and females, teenagers from ages 12 to 17, and it has their heights and weights. And I believe when you look at the literature on this, it says that they're martial arts students. So let's say we want to calculate a confidence interval for these students. Now, it probably wouldn't be a good idea to keep everyone together because on average, the average male is heavier than the average female, and the average male is taller than the average female. So if we're going to calculate confidence intervals for the population mean, height, and weight of these students, we're probably going to want to separate by gender. Now, one way you could do this is to use the add-ins menu. Now, remember, in add-ins, we got these statistical calculators that we installed, and there's this confidence interval for one mean. And, one of the options is, Picture Brain says, hey, what are you going to give me right now? Well, we would give it raw data, and we would say, okay, and then we could use this. The only issue, it's not even an issue, it's just that JUMP has a really nice built-in feature for this, and I kind of like it a lot. So what I'm going to do is, rather than use the add-ins tool that I had you guys install, and I showed you that in a prior video, on the last one, using to calculate a confidence interval using the normal distribution, I'd rather use this time the Analyze feature in JUMP. It's built in. So let's show you that Analyze distribution menu. So what I'm going to do is I'm going to go to the Analyze menu, pull it down, and the very first option is called Distribution. You're going to be here a lot, so get used to seeing it. So Analyze distribution. All right, so it says, what do you want to analyze? Well, let's do the weights. I'm going to grab weight. I'm going to drag it into the Y columns, saying, hey, let's analyze weight right now. But remember, I want to separate by gender. So I'm going to grab the sex variable and pop that into the by field. So in other words, let's analyze weight and separate by sex. And I'll just say, okay. Okay, so notice what it does. It gives us a histogram, a box plot, quantiles. Here's some famous quantiles. These are called quartiles in the middle here, right? That's the 25th, 50th, and 70th percentile. By the way, those three numbers and the low and high, that makes the 5-number summary, which remember is used to create this box and whisker plot. You learn that in Stat 1. And then down here, the summary statistics. It lets you know, some statistics about these females. There were 18 females. Their average weight was 101 pounds about. The standard deviation is about 23.4. All right, fine. Notice what else it does. It gives you the upper and lower 95% confidence intervals. All right, so there's the lower limit, 89.2, 89.3 about, and this is about 112.6. So you can see the confidence interval is from about, let's call that about 89 to about 113. Now, what about this standard error mean right here, that 5.52? Well, JUMP has the ability, and it does a lot of things, obviously. So it's going to move these things side by side. Remember the standard error, it's called SE mean, which is sigma x bar, which in this case will be S divided by the square root of n. All right, and S, the standard deviation, 23.4 357 divided by the square root of the number of samples, and as you can see, that was 18. All right, so in our calculator, 23.4357 divided by the square root of 18. That's 5.52 ballpark. And notice standard error of the mean, 5.52. So there you have it. So JUMP, what it does is it calculates the sample mean and sample standard deviation. It crunches the standard error. And remember what goes on with the standard error. The standard error gets multiplied by a t-score, and then that number gets added and subtracted to the mean to create this interval right here. All right, so there you have it. Now if you scroll down a little bit, you'll notice they do the same thing for male. And of course, you have a confidence interval and the standard error. All those calculations are all there. And if you're wondering over here why this box plot looks different, because it looks like there's an outlier, a potential outlier here for one of the males, as you can see. So one of the males was heavier than most individuals. Who was that guy, by the way? He's about 180 pounds. Probably one of the older fellows, right? Yeah, this guy right here, Lawrence. He's 17. He's 70 inches tall. He was weighing 172 pounds. You can see he's much heavier than all the other guys, so he's an outlier. And JUMP shows us that by this little dot right here on the box plot. All right, so now what else could you do with this? Well, one thing is, what if you don't want a 95% confidence interval? A couple things I like to do also. Let me show you this. Right here on the weight, if you click on that little red triangle, and it is display options, horizontal layout. Kind of like that better because then it's nicer to read, and you could do that for all the outputs. So you could do a horizontal layout. I like the horizontal layout. The nice thing about the vertical layout is it's streamlined, and you can have several of these open at the same time right next to each other, which is kind of nice. So when you do the horizontal layout, obviously it takes a lot of room up on your screen. But another thing I think you should see is that here, the confidence interval, what if you didn't want a 95% confidence interval? What if you wanted, say, a 90 or a 99% confidence interval? So this little red triangle, the red triangle means that there's more things you can do in JUMP. So if you click the red triangle, sorry, it's going to be over here on weight. Click that red triangle. And confidence interval. You can see you can select the three popular, 90, 95, 99, or other. So if I say, let's do the 99, and then right next to, so here's the 95% output. And as you can see, this is the 99%. It tells you alpha 99%, and here's the lower and upper limits. Recalculates the means and standard deviations. So it really, the built-in feature in JUMP really does a nice job with this topic. All right, so now, what if you had, say, summary statistics? What if you didn't have raw data? Well, the JUMP doesn't have a built-in feature for that, and that's why I showed you this add-ins menu. So in add-ins, statistical calculators, confidence interval for one mean, if you had summary statistics rather than raw data, you would use this feature, and you would select, Z or T, and I showed you this menu. So if it was a T scenario, you would input your statistics, input your confidence level, and it would automatically crunch and show you the results of that confidence interval using the statistical calculator that we added in. So for when you have summary statistics, the add-in that we used, that I showed you, is much faster. But if you have raw data, naturally the built-in features in JUMP are excellent, and I highly recommend using them. This concept is also available on the TI graphing calculator, and I know a lot of you guys have been questioning me on that, and absolutely you could do it on air if you'd like. I think you should give JUMP a try as well because it does a great job and the output is really nice. All right, so if you have any questions, feel free to shoot me an email. Thanks for watching.